Hi guys, let's do our last related rates example. Okay, gravel is falling on a conical pile at a rate of 10 feet cubed per minute. So we actually have a picture here, a conical pile. So I'm going to add this little here, make it look like a cone. There's a conical pile, and it's falling into it at a rate of 10 feet cubed per minute. So this is coming in 10 feet cubed per min. At all times, the radius, let's name that R. Oops, wrong one. Hello. R is twice the height of the cone. So R is 2 times the height. Find the rate of change of the height of the pile when the radius is 6 feet. So let's start with our given, implied, and find. So we are given that the pile is growing at 10 feet cubed per minute. That's going to be a growth in volume. That's the rate the volume is increasing. So dV dt. We also know that the radius is 2 times the height. We know the rate of change of the height, so dH dt, is 6 feet. And that's pretty much it. Now let's talk implied. So first off, if we know, oh, sorry, I forgot. I totally did this wrong. Sorry, guys. We want to find the rate of change of the height. There we go. When the radius is 6 feet. There we go. All better now. Okay, radius is 6 feet. Find dH dt. So let's start with implied. First, if R equals 2h, and we know that R is 6, then it is implied that h is 3 feet. Okay, another thing that is implied. We have a volume of a cone, which is 1/3 pi r squared h. That's the volume for a cone. But if I were to take the derivative of this, I'm going to have to do product rule right there, and that's kind of gross. So what if instead of that, I substituted in that R is 2h? Then when I simplify that, we get 4h squared times h. So that's going to be 4/3 pi h cubed. And taking the derivative of that equation is going to be way easier. Now, like I said, you could have done it with this one, and as long as you do the product rule correctly, you would end up with the same answer. It's going to be fine. It's just that when we simplify it to one letter instead of two, it's a lot easier, and we can do that because of this equation. So, we have given, we have implied, we know what we need to find. Let's use our equation. That's going to relate all the variables. So we've got this one. Now it doesn't have R in it, but it kind of does because we just replaced R with 2h there, so we should be fine. Take the derivative of v, which is derivative of v with respect to t. 4/3 pi is just a constant, so I can take that out. And then I take the derivative of h, which is going to be 3h squared, times the derivative of h. And that should be my equation. So let's plug in what we know. We know dV dt is 10. We know that h is 3. and we know we need to find dH dt. So if we simplify all of this, we should get 10 equals 36 pi dH dt. Divide by 36 pi. So dH dt should be 0.088. And this is a rate, so it's going to be per, and it looks like it'll be feet per minute, which I know by looking at that one. Okay, feet per minute. So that's our answer. I still need my sentence. So we're going to say the height of the pile is changing at a rate of 0.088 feet per minute when the radius is 6 feet. We're specifying at what point in time this rate applies. And there we go. That should be everything for your last related rates example. You can get started on your homework.